Welcome, everyone. Thank you for joining today's webinar. I'm Shane Johnson, and today we're going to talk about LLM distillation. But a few things before I get started. First of all, as I said, my name is Shane Johnson. I'm responsible for product marketing here at Snorkel AI. You will find along, I think, the right side of your panel, you'll see icons for chat and Q&A. Please feel free to use the chat if you're having some technical issues or some challenges with the webinar platform. We'll do our best to keep an eye on that. And please feel free to ask questions throughout the webinar with the Q&A panel. So feel free to ask those questions. I'm going to try to make sure that we save at least 10 minutes, maybe a little bit more for Q&A at the end, and we'll try to get to as many of these questions as we can. You'll see, I think there's an emoji icon at the bottom there. So you're more than welcome to sprinkle the screen if you see things that you like that are interesting, or if I tell a funny joke. That's all. See, thank you. Thank you for whoever gave that little heart there. You can also download a copy of the presentation. So it'll also be an icon. It looks probably like a little document copy icon. Those are the resources, and there's a PDF of this presentation in there that's available for you to download. So I think with that said, I'm going to go ahead and get started. Quick agenda. I'm going to spend a few minutes just to talk about, why we consider distillation. What are the benefits? Who's taking advantage of it? Then we're going to dive straight into the weeds and start looking at the process in a little more detail. I'll kind of talk about some of the challenges and some of the ways it can be used. And then we're going to actually talk a little bit about our approach and some of our research. And then, of course, we'll finish with some takeaways. So all LLM distillation for roughly the next hour. Why distillation? What caught my attention and why I enjoy researching it and discussing it with people is that you really can have the best of both worlds here. We're going to get to this in a second. I mean, the foundation models that we see, it seems like there's a new leader, every week, every month, and they are truly amazing. But from an enterprise perspective, there is an option to have the same capabilities you see in those larger, more expensive models, but also kind of reduce your inference costs. Right? You need fewer GPUs, right? Less compute. And you can still get really fast, accurate responses, right? In some regards, actually faster, right? Lower latency, and still get that accuracy. So this, to me, is really the crux of why we consider LLM distillation, particularly for enterprise Gen AI applications, because it's a really great way to kind of reduce costs and still maintain that level of accuracy that you're looking for. And so kind of doubling down on that here, the biggest models are really big. I think Llama 3 came out with a 405 billion parameter model. These models are amazing, and you see them ranking high on all the benchmarks and all the leaderboards, right? They're as good as they are at few shot, they're getting even better with zero shot. But there is a cost to paid, whether it's direct or indirect, right? If you're using, a model provider, you're going to be paying by the token, right? And the infrastructure costs, they're coming through via tokens. Or if you're choosing to run, an open model on premises or in your own VPC, again, right, you're going to be spending more and more on those GPUs. One of the things that maybe, may or may not be discussed is that there's also a higher response latency because more computations have to occur. So these bigger models, they're not only amazing in various concerns from coding to translation to reasoning, but all of that greatness comes at the cost, both of the infrastructure as well as the compute time. So those are some of the things that we're trying to factor in here, because as awesome as they are, they may not be practical in every scenario. So that kind of brings us to, well, how should we start thinking about that? How can we change that? Ideally, we want to compress the models, right? This should, probably not too much of a surprise. we have very big models. Well, we can just compress them and make them smaller. That should help. And there are techniques for that. Pruning, quantization, low rank decomposition. I'm sure there's a few others. These are methods that the sole focus really is just on reducing uh, the footprint of that existing model. And they are effective, quite frankly. But in practice, we don't need all of the capabilities of the very best foundation models, right? I picked a handful of categories here. There's certainly many others, but depending on what you're building, if you're building an AI assistant for customer support, you probably don't need a model that's excellent at writing Python code. You probably don't need something that's excellent at translating text, right? There's going to be a number of things that it can do. It can tell you all about Wikipedia, right? Ask any type of question out there. It's not going to be helpful to you, in terms of what you're trying to build. So we can start by thinking about what is it that we really need from these bigger models for our use case. And the one I'll use here throughout today's presentation is Q&A on health insurance bills, right? They're fairly complex. There's lots of rules, and if you've ever seen how they're explained, there's a lot to account for it. So I might say that yes, you need basic math, but we probably need some pretty good reasoning capabilities to help our customers understand their bills, right? Why they've been charged, what they've been charged. In this type of scenario, the goal is really to specialize the model. So if kind of look on the left there, if all you want is to kind of reduce the footprint so that you can kind of lower costs and lower latency, those techniques I mentioned before are great. If, however, you want to create a specialized model, something that's very good within your domain, right, and you have a whole bunch of unlabeled data available to you, distillation is the technique that we should be looking at, right? That's the method that's going to get us to where we want to be. And so, kind of coming back full circle here, yes, this is an approach that can give us faster responses, lower inference costs, but still retain those capabilities that are critical for our use case, right? For whatever type of AI assistant or co-pilot that we're building. And I wanted to take just one little sidetrack to show this in action. I think this came out last year, if I'm not mistaken. But what I thought was fascinating about it is that when we typically think of a new series of foundation models, we kind of assume that okay, we took this huge corpus and we trained the very biggest model in this series, and then we pruned that corpus right into smaller and smaller and smaller amounts, and we trained smaller and smaller models, which is why you might see a series of foundation models that range from 8 billion parameters to hundreds of parameters and a handful in between. NVIDIA took a more novel approach. They had, this Nemotron 4 15B model available, and they were looking to create 8B and 4B models. So what they did is they first pruned that big model down to, roughly half its size. So that was one of the techniques I had mentioned at the beginning, just in terms of sheer compression, produced that. But when they pruned it, it's obviously not going to be as good, right? There's a lot that gets lost in that process. So they actually used distillation to retrain the 8B model. And then you can see they pruned the 8B model again in half to get to that 4B model. And then again, they used distillation to retrain that 4B model. So in a sense, they're, squeezing the models in half and then accounting for the loss by distilling knowledge for the bigger model back into it, right? And just looking at the chart kind of says it all, right? Significant improvement from Nemotron 3, 8B up to Minitron, 8B, and even the 4B model was better. So I thought this was an interesting case of looking at how NVIDIA, is approaching this. And if you have a chance, I think that research paper was a great read. Now we'll get a little bit into the weeds, right? In terms of the distillation process itself. It can sound like a lot in some of these slides. It might start to appear, like it's doing a lot. But it's actually pretty simple, right? We're gonna essentially ask the teacher some questions to get very good answers. Then we will take those questions and answers and we will use them to fine tune the student. Right. So it is, I'd say at the surface it is pretty simple, right? We just need to extract the knowledge from the teacher, right? Just by prompting it, right, and capturing its response, and then use those prompt response pairs to do fine tuning, right? And there's different techniques for fine tuning that you can choose. It's kind of irrelevant, right? The point is that the training data is being generated with the help of a bigger foundation model. So one thing I sometimes hear is kind of these questions between distillation and fine tuning. I kind of look at them as two sides of the same coin, right? Distillation is really fine tuning with training data that's been labeled by a foundation model. So, kind of overview of the process. As I mentioned before, let's try to identify which capabilities, right, which tasks we need our model to be good at, right, and what we want to extract from the teacher. So it could be information extraction tasks, classification tasks, summary tasks. There's lots of different types of tasks. What's important to you, right? What are you trying to build? Then we need to design prompts, and this is where I would say a fair amount of thought has to come into play, because it's really it's not just as simple as asking the question, right? We need a prompt template, and we need to probably iterate on it until that larger model is producing responses that are going to be helpful to us. So that's a big piece. I'm going to pause maybe for just 1 second. I know I'm following the chat and I see there's a few folks here that may be having some audio visual issues. So if that continues, we'll have someone responding in you. If this happens to a lot more of you, feel free to also say something in the chat. I'll try my best to keep an eye out in case I'm starting to lose folks here. But if it's just a handful of people, I'm going to assume that the rest of everyone can still follow along. So yeah, designing those prompt templates in the right way, right? You wanted to ask a question, you wanted to provide the rationale, maybe you wanted to rank responses or generate synthetic data. All of these different scenarios are going to require curated prompt templates to get what you want, because even though the larger model has all of that say knowledge and capabilities, for lack of a better word, sometimes it can take a bit of work to get that out of those models. The third is preparing input data, right? So generally speaking, you need some seed data to get started. If you want to extract, useful information and capabilities from a foundation model, we need some way, right? There's got to be something that fills in those prompts. So we're looking at things like examples, documents, anything that can be helpful, right, in this process. So think about what is that seed knowledge that's kind of going to be that spark to help you extract more powerful capabilities out of this larger model. And then the last one, and it's okay if this isn't immediately clear because I'm going to go into a little bit more detail on this here, is where we want to extract the knowledge from. And this part gets a little dicey because there's different points in the generation process where we might want to intercept that knowledge. On the surface, when I say predictions, I'm typically mean the actual tokens, right, or the actual text response that comes back from an LLM. But beneath that, you have things like probability distributions and logits. And if you're willing to perform open heart surgery, you can dive right in, and actually extract features from kind of intermediate hidden layers. It of course tends to be a little bit more complex, but again, if you bear with me here, we'll go through a few diagrams and try to explain this a little bit better for you. At a high level, I picked these two. I think they're going to be easiest to get started with. One is, what are you going to fine tune with? So in terms of predictions, and you might hear me say labels, predictions are hard target. They're kind of interchangeable, but that's when we're trying to focus on natural language generation, right? We want our student model to generate responses similar to how our teacher model is, and you can see a handful of fine tuning techniques are available to you there. If you start to go a little bit deeper into things like probability distributions and potentially even deeper than that. Now we're trying to actually get at that natural language understanding, right? We want to, capture that large models, kind of nuanced understanding of things, right? In terms of how it reasons, right, and how it handles these tasks. And then there's kind of different, slightly different approaches for how you transfer that. So you can see a couple examples here. I just talked about Minitron from NVIDIA. They use KL divergence. DistilBERT actually use a combination of cost entropy loss and KL divergence. So there's different methods you can use in that regard. And again, I'm going to go into a few more details on these in just a minute. So looking at this process and pretend that this is our teacher model, right? This is some really amazing large, powerful open model that's available to us. Hint, hint, DeepSeek R1. Where the knowledge resides and where you extract it is up to you. But some approaches are easier than others. So if I start on the right, those tokens, right, the responses that are generated, we can train directly on those, which is kind of how we've been using supervised fine tuning for a long time, I guess, in that regard. You could go a little bit deeper into the probability distributions, refer to those as soft labels. You can actually go deeper to the logits. And if math and complexity are your thing, then certainly you could actually try to extract the features from hidden layers. So that's what I meant before when I said that there is a number of places where this knowledge exists. At the surface level, you're really trying to, I guess, teach the student to imitate the teacher, for lack of a better word. Whereas if we dive deeper into things like features and logits, now we're trying to actually, bring over some of that deeper understanding into the student. So a little bit of kind of the workflow here, what it looks like. Simple question: why is the hospital billing me for this? Right, I've already paid my deductible. This is supposed to be covered, right? Whatever it might be there. That goes into your larger teacher model. And then you basically pass the same question into your student model, and it has its predictions. And then we use a loss function to compare the two, right? And then back propagation to help improve our teacher model. So I'd say this is kind of the superficial perspective of what this looks like. As we expand on it, again, we could start here. So maybe we'll get down into probability distributions. We'll choose our loss function, and that is essentially what we refer to as our distillation loss, right? What's being lost in this process from teacher to student. You could go a little step farther and kind of take those hard labels, right? The tokens or the text responses, both from the teacher and from the student, right? And then you apply a loss function there. I chose cross entropy as the example in this diagram, and that represents the student loss. So mentally for me, I think of distillation loss as being more around the understanding of the task and the solution, and then the student loss being kind of the actual response, right, and its correctness. And then you can actually go a step farther and use both of those to calculate your total loss, and then again, pack propagation to train the student model. So there is a handful of approaches here. You can combine them as well. But in a nutshell, we're just trying to transfer knowledge, right? Capabilities from a big model to a small model. Next, I wanted to touch on some of the research that we've been doing here at Snorkel over the past couple of years. Some of this is a little bit newer, and some of this is before that. I'm going to start with an LLM distillation technique. So understand, that some of those diagrams we were just looking at, it can make my head spin when I start thinking about loss functions and logits and knowledge transfer. And some of these things, I still bring them up, but they predate LLMs, right? These are the same techniques that were used to, you know, perform distillation with machine learning models as well. But what I think is fascinating with LLMs is that it is much easier for us because we can actually just work with the responses from the LLMs. Like, we don't really have to get under the covers to get what we're looking for. And this particular method here, distilling step by step, this was some research performed by Snorkel and Google. The idea was not, we don't want just the responses from LLMs. We want the rationales behind those responses. And you're probably starting to hear a lot more about this lately because reasoning is such a big deal after DeepSeek R1. And there was also I think it's QWQ32B preview is another great open reasoning model. So lots of progress has been made there. Even though this predates, these models, the idea was the same, which is with chain of thought, we can actually, extract pretty helpful information. Right. So it's not just the response anymore, but how did the model get to the response? And if you think about kind of the resources behind it, and I'll show you some charts here in just a little bit. But the one you see there right now, we trained a T5 model, right? This is less than a billion parameters, and it outperformed, 500 billion parameter model significantly, right? And with just a fraction of the data, actually. So it is a very real thing, right? As much as I hand wave at the beginning about how it can be faster and it can cost less and still be as good. The research tells us that we're not just blowing smoke here, right? This is very legitimate. Obviously, we're also task focused, right? So we're not trying to replicate every capability of a 400 or $500 billion parameter model, but we can effectively capture a slice of that, right? That's important to us. So, little example here. Uh, at the very top is our few shot example, right? So, here's an example where we ask a multiple choice question. That blue part would be the label, right? That's the answer. So, tell us that. But then also, we need the rationale in green, which explains how you got to the answer. And so, when it comes to generating our training data, we then provided those additional inputs you see in the middle. And lo and behold, we're getting similar outputs. And those outputs are what we're going to use to fine tune our smaller model. And here, hopefully, this looks better for you. It's looking a little fuzzy for me at the moment, but that's okay. The concepts will still come across. Is we take advantage of multitask learning. So we have this input data. This is kind of the seed data that I'd mentioned a little bit earlier, right? You need some seed knowledge and data to kind of induce that teacher model to generate what you want. And so we go through that exercise and we end up with a whole bunch of essentially labeled questions with their rationales. And then we do the training on two pairs, right? We train on essentially the question and the answer, and then we train on the question and the rationale. And a little bit, I'll go through kind of some of these. I'm not going to go into extreme detail on them, but the big takeaway here is that this approach was far more effective than standard fine tuning, right? Particularly in the first two benchmarks you can see there. But that was still the case on the right two as well. Also, kind of notable is the training set size at the bottom, right? So obviously at 100%, we're seeing the best, but even at 25 to 50%, still outperforming standard fine tuning. The inverse of that is outperforming standard test distillation with unlabeled data, right? So when we don't have the answers to all of these questions or the rationales behind them, we are still going to get better performance over even standard test distillation, right? And a big part of that, of course, is the rationales. that we're slitting. So we're not just imitating the response anymore, we're imitating the reasoning behind the response. And then here's one a little bit more clear on the difference of these two models, right? So one is really, really quite small compared to the other, but the distilled T5 model continued to outperform that Palm model, even with few shot chain of thought. So it outperformed it with standard fine tuning. It even outperformed it with few shot COT as well. And then finally, similar thing, versus traditional distillation approaches. So the net here is that distillation is probably even more effective today because of how good foundation models have become at reasoning, right, and explaining their decisions and rationales. We don't have to actually go into features and hidden layers anymore to grab that, right? They're actually sharing it directly with us. The next project, and I'm going to be substituting in here for Charlie, who would normally present this. This is his research. So hopefully I can do some justice to it. And he was not able to join me today. But taxonomies are particularly important. We find a lot of uses for them when we're working with our customers. And you can see kind of the two call outs here were error analysis and curating data sets. But generally speaking, building a high quality taxonomy takes time and can be expensive, right? Especially if you need SMEs, right? A lot of their time to help you flush out a very sophisticated and accurate taxonomy. What we researched was an approach that does incorporate an SME in the loop, but it essentially is combining SMEs with large foundation models to help us iterate and refine. And so, kind of striking a little bit of a balance here, and I'll explain why it's not just one or the other. But we would start with SMEs to help us kind of build some taxonomies to get started, right? It could just be the first couple of layers. Then we can use foundation models to expand upon those taxonomies. So when you see that data on the right side, we're giving it stuff that we want it to classify, for lack of a better word. So it's continue to classify these items with greater granularity. They come back to SMEs, and then the SMEs can certainly continue to iterate on those taxonomies to the foundation model again for refinement. So there's a little bit of a loop there. We provide an SME domain knowledge, we incorporate the data, and then we have this cycle between our teacher model and our SMEs. So, what I mean earlier when I said that, it can be a little bit, let me rephrase. The reason I wanted best of both worlds, right? If we're using just an SME, it's going to be, a time issue and potentially a cost issue, right? Because their time is certainly not cheap. Foundation models are getting exceptionally good, even at zero shot hierarchical text classification, but they can still also be a little bit slow and expensive. And this was the example that came from this research. 65,000 instructions were essentially passed to a foundation model for classification. 74 hours, $1,400. Now, I guess in the grand scheme of things, right, in an enterprise environment, $1,400 is not going to sound like the end of the world. But when you start trying to do this at scale, that money adds up and that time adds up. So it's kind of the question is, well, how can we benefit from the expertise of SMEs and the strong capabilities of foundation models while at the same time doing this faster and cheaper? So using distillation, right? We had 65,000 instructions, and that top part there is just a repeat, right? 74 hours, $1,400. In the second example, 10,000 examples are pulled from that training set. They were then used to, generate the responses for the instructions, then train a smaller model on those instructions, then pump the 65,000 through for the prediction. So that's why you kind of see the two times there. The first 15 minutes was really just the process of the distillation into that small model. The next 13 minutes was then actually doing the full classification on the instructions. So much, 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 much faster, and it's essentially free, right? With these small specialized models, you can run them, locally on premises. So there's virtually no cost associated with them. And speaking on behalf of the team here, this research made its way into Snorkel Flow via extension. So, in short, we have applied ML and research teams, and they tend to work with our customers to solve kind of the most challenging problems. As we develop those solutions, we then try to package them up and bring them back into the product so other folks can benefit from the same learnings. All right, LLM distillation key takeaways here, right? So we're kind of approaching the end. A few thoughts to share with you, and then, as I said in the beginning, we're going to have plenty of time here for Q&A as well. One, this is a proven and effective technique for reducing latency, lowering inference costs, and improving accuracy in some regards. I mean, I guess you're not improving it in the sense that you're making the teacher better, but that student model is certainly going to reflect the accuracy of the teacher with specific tasks. There are some challenges, though. One is that a lot of the examples I talked about in our research is around distillation from open models. So there's a lot of closed models where you can't always extract deeper knowledge, and there might even be licensing restrictions that prevent you from extracting that knowledge for the purposes of training another model. You don't always have that option available to you, and sometimes it's just a sensitivity issue where some enterprises are not comfortable sending real world or representative data to an external foundation model, right? To get it labeled and to get that rationale. Even if the net result is a smaller specialized model running on premises, it does require that data to potentially be exposed to a larger outside model. And then the other one is that, certainly if you want to start extracting, probability distributions, right, and doing feature training, that is a much more complex effort involved. But the good news on the first one is there are some really impressive open models. When I originally designed these slides, Llama 3 won 405B. I was pretty astonished by it. It was open. It was rivaling GPT 4.0, but at the same time, it wouldn't necessarily be practical to deploy a model that large in production, depending on what your use case is. Um, you can see there 800 gigs of GPU memory. Generally speaking, 18 times higher inference costs over smaller models. So not very practical for production, potentially perfect as a teacher. And same thing for DeepSeek R1. I just wrote an article the other day summarizing a research paper out of UC Berkeley where they were distilling reasoning capabilities from DeepSeek R1 into a smaller model. And they found a lot of success with that. So, yeah, the open models, it's amazing what's happening there. And then in terms of the other one, you can look at solutions like Distillation step by step that I talked about a little bit earlier, and keep in mind that these models are extremely good at justifying their answers, right? At working through and generating reasoning steps, coming to the correct conclusion, right? Generating long chains of thought. All of that information we can use directly to fine tune a smaller model. So remember, it's not just the answer. We don't want to teach a small model to simply repeat the same answer, but we want to extract the rationale, the reasoning and the logic behind it, and then transfer that to the student model. And then finally, one little kind of final note here in terms of Snorkel and how we look at it is despite some of the complexity you've seen in some of these slides here, and maybe as I had mentioned at the beginning, it doesn't have to be that complex though, right? Especially when we can do distillation and fine tuning on rationales and answers. So when we work with customers, the idea is, all we need you to do is import, the unlabeled data available to you into Snorkel Flow. From within Snorkel Flow, we can actually prompt your teacher, right, or the foundation model of your choice for labels, right, to get those answers, to get those rationales. Then you would typically have the AI team do some curation, right? You might not want to fine tune your model on all of that data. So you want the highest quality data there. You might want to assure that your training data has the appropriate distribution to support the range of tasks that you expect from your Gen AI application. But once that data has been properly curated, then despite my slide saying LMM here, I'll have to fix that typo after this, you would then fine tune the LLM, right, and create your own specialized model that you can run. You can certainly run, on the inference provider of your choice. You can even run it on premises as well. So sometimes it can feel a little dicey, at least to me, but in practice, it's actually getting quite easier, and tools like Snorkel Flow can help with that. All right, so that was 40 minutes of me on LLM distillation. I know there was a lot of activity in the chat, although it looks like a few of you folks that might have had issues, I think they were resolved. So I hope you were able to kind of catch up and still gain something from the discussion here. Uh, and next, I want to start taking some questions. Thank you for the emojis. As a presenter, it's always nice to see, and I do want this information to be helpful and valuable to all of you. I know we're all busy, so if I'm taking an hour of your time, I better make it worth it. I'm going to start with the Q&A tab first, though. And I know my colleague Katie is on, and I think she will help me. We can also take some live questions too. So if you want to raise your hand, we can certainly bring you up to ask your questions. Otherwise, if you're more comfortable dumping them in the Q&A panel, I'm going to pull from there too. First question. Do we start the student model with a pre-trained state, or is it initialized randomly? Generally speaking, I guess there's two ways to go about it. I'm kind of thinking where my starting point should be in my head. The student model is going to be your choice in terms of what you want to fine tune. We've seen folks pick open models, and then range from say 8 to 32 billion parameters. There is certainly a lot to choose from. So you kind of have to pick one that you want. Now, in terms of kind of the order of things, it's a little interesting. I mean, I think in practice, if I really wanted to go all out, I would probably want to fine tune the teacher on my own data. So if I'm building this AI, assistant to help with, customers answer questions on healthcare bills, I would probably want to fine tune the teacher model, so it understands more about these bills, the types of questions, how to answer those questions, etc. Then I would do the distillation. So I'm kind of pulling out, very clear understanding and capability of answering these questions, right? And using those examples to train the student. Let's see here. Second question. In the process of distilling the model and removing generality, do you lose as well capabilities in your specialized model? If you're specializing a SQL generator model, this specialized SQL model is not as good as the generalized one. So that is largely correct. I had mentioned before, I was reading a research paper the other day where they were doing reasoning distillation from DeepSeek R1 into a smaller Quen model. And they had some ablation studies, but they actually found that the um, the distilled models still performed well on a range of tasks, right? They're probably a few percentage points lower, but they still retain a fair amount of generalizations. I guess despite what I said in the beginning, it's not like you lose 100% of every other capability than the one you want. There's still generalization there, but depending on the benchmark or the task, the performance is going to drop to some degree, whether that's a couple of points or 10 or 15 or 20 points. So yes, if you're creating a very small specialized model to generate SQL statements. It may be able to handle, a range of other questions, but it's going to get, probably less and less effective the farther you stray away from SQL generation. Yeah. So this was, kind of, can we go over the step-by-step part where you showed questions were sent to a large model and feeds the small model? In the distillation step-by-step approach that I was going through, a prompt template is created, which is asking the model to answer the question, answer a multiple choice question, and provide its rationale for why, it chose that answer. And then we used few shot examples, of course, to help drive that. So what ends up after that is you have to have some list of unlimited data, which is really your questions, for example, right? 1,000 questions, 10,000 questions. We'll then push those into the teacher model. And for each of those 10,000 questions, we're getting the answer and the rationale. In the transfer phase, we do it with two tasks. The first task trains the student on the original question and the correct answer, which is kind of the more traditional approach. And then the second task trains the student on the question and the rationale. And that what helps it be more effective than kind of previous approaches because we're incorporating that rationale into the transfer process. Are there specific student model architectures purpose made for distillation? You know, I I don't think so. At least I don't know off the top of my head. One thing I realized that I didn't mention today, and I wish I would have. I'll make a mental note for next time. Is that in terms of distillation, we would suggest that your teacher and student models share the same architecture. I wouldn't say it's an absolute requirement, but especially if you plan to go deeper into those um, logits and hidden layers, then you almost certainly have to use a teacher and student that have the same architecture. If you're using distillation, close to the surface with answers and rationales, then certainly you have greater flexibility. What method is used to tune the student model? Is it supervised method like Dr. Laura? In our particular example earlier, when I was talking about T5 and Palm, I'm not sure what specific method they used, but I would say a fair amount of the research I've seen suggests that whether you're doing supervised fine tuning or LoRa, they're both going to be more or less equally effective. One or the other might be a point or two lower or higher, but yeah, it seems like LoRa has become really, really quite efficient and effective. How well does this process work for an organization that was entirely self-host, where the vendor would not have access to the environment? In other words, how much is the Snorkel Flow product a plug and play capability? So Snorkel Flow can be deployed on premises. It can be deployed in your own VPC in the cloud, or we can run it in the cloud and manage it for you. So I guess in one aspect, Snorkel Flow is kind of neutral, right? It can be deployed anywhere you want it. On the other aspect of it, in terms of Snorkel Flow's ability to integrate with and use foundation models, that is also true. Where those foundation models are running is not a factor, right? We could certainly use a model that you have on premises. We can go out to OpenAI or Anthropic. It's kind of up to you. We're neutral in that regard, right? We kind of play in the middle. We'll run where we need to run, and we'll integrate with the foundation models we need to integrate with. So I see a great question here on back propagation and kind of how does that work and tools to tweak the parameters. That one I'll have to save for another day. That I could probably make that a webinar in itself. So maybe one of these days I'll do a deep dive on fine tuning, and we can go a little bit more into loss functions, back propagation, and some of the mechanics that are happening under the covers. So apologize, I can't quite give you the right answer here, but maybe in another one we certainly can. Do you have models trained with medical benefits data at Snorkel? Do we select models for both teacher and student? So I guess the short answer for your first question is yes, we have worked with customers to build models in the healthcare slash pharmaceutical space. I wouldn't say those are our models though, right? So our customers use Snorkel Flow to build their own specialized models, and we help them with that. But yes, that is the case. Do we select models for both the teacher and the student? You do. So it's entirely up to you what each of those are, quite frankly. Could you please elaborate on how do you get the rationale behind the output of a teacher model? Isn't that rationale embedded in the hidden layers of the teacher LLM? So that's a great question. And generally that was the case, right? I think early on, distillation would have happened at that level. And I think that was the case for NVIDIA too. I'd have to go back and double check the research paper. But I think they were actually, cracked open those models, right? And were kind of pulling out that knowledge from deeper within when they did distillation. But in a general sense, the very latest foundation models are very good at reasoning and explaining themselves. And I think that's probably why we're seeing a little bit of shift here, is that we kind of had this notion of chain of thought, right? I don't know if that was what 2 or 3 years ago. And all of a sudden that became kind of the go-to standard for everybody was to prompt LLMs and ask them to produce a chain of thought. And it was very helpful. And we saw that in distillation step by step. Now, with the more powerful reasoning models, they actually generate what you might hear as long chain of thoughts, right? So these are multiple steps involved in a fair amount of details within each step. And what's interesting enough is that some of these models, I think trying to figure out the right terms, I would say techniques like self-reflection, backtracking, that they'll actually change their reasoning steps, right? They might, you know what, this is going down the wrong path. Let me change, right, or let me pivot. So they're actually really, really, really quite good at that. There's always room for improvement, of course, but they're quite good. And I think, at least from my perspective, that's why we don't necessarily have to go into the hidden layers anymore. Is that these long chain of thoughts, um, as the name implies, are very, very long, right? I think thousands of tokens of information on how they got to the conclusion. And ultimately, if we can use that to train the student, then the student should be able to essentially replicate, right, those reasoning steps, or in some sense also generalize them too. But it teaches them how to reach the conclusion instead of simply copying pasting that conclusion. Let's see here. Okay, so I think Katie, thankfully, copied some of these questions from chat, and she got me them in the Q&A for me. So thank you. I was just going down that list here. I don't see any others, and I know we're closing in on the top of the hour here. If you do have any last minute questions, we'll hold for a minute or two here in case you want to drop those into Q&A, or if you have any other feedback that you'd like to share with us or in the chat, by all means. But otherwise, that's kind of the end of my bit here. So, like I said, I hope you found this helpful. I hope you found it useful. I am pretty excited about distillation, particularly in the enterprise. Right, I think we're going to see a lot more enterprise AI teams looking at distillation, as a means to meet their goals, especially as foundation models get better and better. And yeah, if you have a chance, check out some of the research. It's pretty impressive what's happening in this space. I don't see any more questions. So thank you again, and I hope to see you next time. Bye, everyone.